1, 9. So the idea here is we're going to solve word problems with one variable. Okay, so we're not just setting them up like we did yesterday, but we're going through. So let's take a look at this first one. When you see geometry, what should you do right away? Right away when you have geometry. Draw the figure. Draw the figure. So when you hear isosceles, you may not have taken geometry yet. Maybe you've seen some geometry though, I'm sure, in middle school. What does isosceles mean? Anybody know that one?
Like 3 different.
That's equilateral.
No, 3 different sizes.
Oh, no, that's scalene. Yeah, very good. That's one that most people don't remember. What's isosceles?
It's like there's a smaller base with 2 sides the same.
2 sides are the same. Scalene, none of the same. 2 are the same for isosceles. Equilateral, all 3 are the same. Okay? So when we see this, we see base angles. So Mike was trying to demonstrate with his arms there, and that's the way you want to draw these. Usually, isosceles triangles, you draw them so that the legs, so that the legs are the like vertical ones almost, and that the base is its own. Okay? Usually you draw them so that the sides are the same. Okay, and the base is its own length or different from the others. So we're told that each of the base angles has a measure that is 30 less than the measure of the vertex angle. 30 less than right away means minus 30 from something. So what should I do? Ben, how should I start this one? If the base angle is 30 less than the vertex, what might you want to do to help you? So you're going to be subtracting 30 from something, right? So the base angles are definitely going to be something minus 30. That's an angle symbol, sorry. The base angles are definitely something minus 30, but what is it? What minus 30?
90.
Not 90.
Wait. Is it 270?
It's not a number.
Oh. So, like X?
Yeah. Okay, so we need to define the vertex as x, folks. Look, if I define the vertex as x, then I can define the base angles with regards to the other 2. Again, if the top is x, and we're told that the base angles, that each base angle is 30 less than the measure of the vertex, these base angles are both now x minus 30. Okay? This is the kind of stuff you need to be able to do for sure. I'll tell you right now. So we have x minus 30, and x minus 30. Redeem yourself. Ben, what do the angles of a triangle add up to?
270. 180.
180, there it is. That's what I thought you were saying. Good. So we have x plus the quantity x minus 30 plus the quantity x minus 30 equal 180. Okay? That's our setup. What do we do now? Anybody? What do we do? We don't need to distribute. Right? There's a plus sign. Be careful. If there was like a 2 in front of here, right? There would have to be a number right in front of that parentheses there or there. Okay?
Combine the variables and negative 30 and
Yeah, combine your like terms. So I have 3 x's over here, and a negative 30 and a negative 30 is a negative 60. Again, x plus x is 3 of them. Negative 30 plus negative 30 is indeed negative 60. And then from there, I just solve the equation. Add 60 to both sides, giving you 240, and divide by 3, giving you 80. That's the vertex angle. So what are the base angles? It's me? 50 each. Good, 50 each. Nice and loud. I can't hear you the first time. So the base angles are 50 each. Okay. So we solve for the 3 angles in the triangle. That should be a rather straightforward problem. This on an SAT would be between like an easy to medium level problem. Okay, so keep that in the back of your mind when you're doing these. If you're struggling with these, it means you need to either maybe practice a little bit more, do a few more problems at home, maybe watch some, you know those extra videos I post at the end of the notes? I put those links to videos. Those are all videos pertaining to the topic. So if you go to the end of 1.8 or the end of 1.9 notes, the videos, the links, they're all word problems. And they're people just solving them, going over them. That's one of the best things you can do if you're home and you're struggling, is watch and understand more and more problems. because you see more ways to solve them. You see different ways to solve them. Like Luca yesterday solved that problem a different way than we did and got the same answer. So you're going to see different interpretations of things, which will help you to be a little bit more open-minded and think outside the box for these. Okay? So really advocate for yourself. Or obviously, like some of you did this morning, I was happy to see. I saw 3 of you this morning, which was great. Look at number 2. Why don't you work with the person next to you and see what you could set up? Okay? If there's nobody directly next to you, maybe Luca, come up here and work with Will, please. Okay? But after that, everybody has somebody next to them. So just pair up with the person next to you and just discuss. Talk about your let statements. Talk about what's going on in the problem and what you could set up. And we'll see where we're at. Less than twice the income from the children's tickets. Well, the income from the children's tickets is right here. But it's 30 less than twice that. So what do I have to do? How do I change that if it's twice that?
160x times 2.
Yeah, so or 2 times 160x, either way. Yep. And that's your equation right there. And now you just have to solve algebraically. Again, we take that last sentence and break it down into parts. The income from the adults' tickets. Well, that's this first half of the equation, the left-hand side. Okay, that's right here. When I see the word was, I put an equal sign. 30 less than means put a minus 30. 30 less than twice the income of the children. Here's twice the income of the children. Okay, at this point in time, it's just solving algebraically. I'm assuming everybody can do this. Distribute the 200, please, to make this 200x plus 300 it would be. Equals 320x minus 30. Combine like terms and solve. Okay, I'm going to leave that for you to solve and tell you that you'll get x equals 2.75. X equals $2.75. So what was x in the beginning? Go back to your let statements. What was x in the beginning? Well? Children's cost. So the children's ticket is $2.75. So it makes the adult ticket $4.25. It's $1.50 more. So again, remember, you're asking how much does each ticket cost? So you have to make a statement, some sort of verbal statement. Okay, and then the adults are $1.50 more than that. So just tack on 150, giving you 4 1/4. Okay? Any questions on this problem? If you struggled with it in the beginning, it's okay. It's not the end of the world. But the idea is that you have to be able to understand afterward at least how we translate it. So as you go through the problem, as I talk about the problem, understanding that, the word was meant equals, or the income from the adults, that's the left-hand side of the equation. Or just writing the fact in the beginning, the let statements. The let statements are so important. If you're trying to find the cost of each ticket, let x equal the cost of the children's ticket. Then let x plus 1.5 equal the cost of the adult ticket. Okay? Yes? All right. Let's go look at number 3. Can I get someone to read for us? Nice and loud.
Log of city planner has 2 pieces of metal wire of equal length. He shapes one piece into a square to represent a new building site and the other into an isosceles triangle to represent the nearby park. The base of the isosceles triangle is 4 centimeters shorter than the side of the square, and each leg is 9 centimeters longer than the side of the square. How long is each piece of wire?
So imagine you had 2 pieces of wire, and I could actually demo this. I have 2 pieces of wire in bend right now. So I got 2 pieces of wire here, but I need them to be equal. Hold on, let me find 2 equal pieces. So I got 2 pieces of wire, and one of them I want to bend into a square, and the other one into an isosceles triangle. Okay, but they're equal in length. So I'm taking each of them. Let's say this is the square. 1, 2, 3, 4. It's not bad, right? So there's your square from the 1 piece of wire for the first one. And the second one, we want to make this into an isosceles triangle. So let's make this the base. Okay, and there's our isosceles triangle. It's not really maybe perfect, but that's the idea. Now, what we're seeing clearly is that we have the same exact wire to start, but the side lengths are different. Right? These side lengths are all the same because it's a square. These are different, and they're different from the square itself. How would I label these sides? How would I label these sides that would help me in this problem? What would be a good setup? What would be a good setup based on what I know about the problem? Kelly, go ahead.
Basically, like the last isosceles triangle would be both s plus 9, the other one would be s plus 9.
Why?
Because the legs of the triangle are 9 centimeters longer than the side of the square.
So you're letting the side of the square equal s then, right?
Yeah.
Okay, so that's the first statement we make. Let the side of the square equal s. Then you define the other side lengths in terms of s. So yes, the side lengths here would be s plus 9 and s plus 9. And what about the base?
That would be s minus 4.
S minus 4. Very good. Are we all clear on this? Does that make sense? Now, what do we know about these wires to start? What was the whole idea about the beginning of the problem? They are what? What's the important part, Nina? They're equal in length. Therefore, in geometry, what would I say? The what are equivalent? Not the area of each polygon, but the perimeter. Good, Sabine. So, on the right side, what's the perimeter of a square? Oh, they're S's, not fives. S's. So, add 4 S's together, you get 4S, right? I'm like 20. Where's he 20? What would the perimeter of the rectangle be? The triangle be if you simplify it? How many S's do you have?
3.
Good. 9 plus 9 is?
18.
18 minus 4? So 3S plus 14 equals 4S. Again, the wires we started with are equivalent in length. They're the exact same wires. So the perimeters that we had should be identical. So God bless you. We set the perimeter of each equal to one another. Here's our equation. Perimeter of triangle equals perimeter of square. I'm just writing that so I know what I'm doing. Perimeter of the triangle, there are 3 S's there, and there's another 14 extra units. The square, there are 4 S's. I simply subtract the 3S from both sides, giving me S equals 14. Okay? Lo and behold. Now, what did the question ask of us? What was the exact wording? We got the.
How long is each piece of wire?
How long is each piece of wire? Well, if S is 14, and 4 of those S's made up the square, and the square was a piece of wire, what's 4 times 14? 56. Very good. 56. Does that make sense, folks? Make sure you think about this physically. What's happening in the problem? Okay, that's why I grabbed the wire from the cabinet, just so you can see. I mean, it may help some, may not help others. Maybe just writing it out makes it easier. Okay, but each length of wire was 56, and what are the units that were given? Centimeters. And I really encourage you, and I'll write this in the test, okay, to answer with some sort of a verbal statement at the end. What do I mean by a verbal statement? Yeah, like a sentence or like something stating what's happening. There are 56 centimeters in each wire, or each wire is 56 centimeters long, or something of that sort. Okay? Because it reminds you to check what the problem is asking. Don't just stop when you solve. It's very, very, what's the word? Tempting to stop once you solve an equation. Because in math you always learn, solve the equation, you're done. You got the answer. But you need to actually figure out what they're asking of you, not just what the answer to the equation was. Okay? All right? We've got an interesting scenario here. We've got a truck leaving New York City at 2 p.m. Okay, leaving for Queensbury, traveling at 40 kilometers an hour. At 3:15, a car leaves Queensbury, traveling for New York City at 55 miles an hour. The truck and the car passed each other exactly 2 hours after the car left Queensbury. How far is it from New York to Queensbury? Now, it might be useful to draw yourself a little bit of a diagram. So, what's happening in the beginning? A truck is leaving New York. So let's put New York over here. All right? And it's 2 p.m. right now. The truck leaves New York at 2 p.m. and it wants to go all the way to Queensbury. Let's call this Queensbury all the way on the right. And if it wants to go to Queensbury, it goes toward the right, traveling at 40 kilometers per hour. All right? Now, at some point in time, at 3:15 precisely, a car leaves Queensbury and travels the other direction. Yes. It travels the other direction. So another car leaves Queensbury traveling toward New York City. Let's draw that in red. So that car is going this way now. Okay, and that's exactly at 3:15 p.m. So let's say that the car leaving New York is right here at 3:15 p.m. Okay, then it says after that, it's traveling at 55 kilometers per hour from Queensbury, so let's label the rate there. Then it says that the truck and car passed each other exactly 2 hours after this car on the right leaves Queensbury. After that car leaves Queensbury, so what time are they going to pass each other at? 5:15, right? Because again, this car leaves at exactly 3:15 p.m. from this location. And at that point in time, this car has already traveled some distance. And now they're going to meet at some point in between those at 5:15. So let's draw this now to here. Okay, and we'll say that they're going to meet up maybe like right here. And this is at 5:15 p.m. What I'll do is I'll extend this arrow so we can see what's happening. All right? So then the question says, how far is it from New York to Queensbury? So what are we looking for at the end of this? What are we actually looking for?
The distance traveled.
The distance traveled. So what kind of an equation might I use in these problems?
D equals rate times time.
Yeah, distance equals rate times time. So let's think about that in the back of our head. So what we're going to start with is the fact that the first truck left early. And how long did that truck travel for before the other car started leaving? Kelly?
An hour and 15 minutes.
An hour and 15 minutes. Again, this car travels from 2 to 3:15. That's an hour and 15 minutes. Now, how far have they traveled in that distance or in that time period is the question. How do you think of an hour and 15 minutes when you're using distance rate formulas?
1.25 hours.
Where is that coming from? How do you know it's 1.25?
It's 15 is a quarter of an hour.
Yeah, on a clock, 15 minutes. You need to know your clocks well, by the way, time. 15 minutes on a clock is a 90-degree angle, isn't it? From the 12 to the 3. That's a quarter of the circle. So it's a quarter of an hour. So after 1.25 hours, right? After 1.25 hours, it has traveled. So what do we do to find out this distance right here in black?
I did it sort of mentally, I guess.
Okay?
If it was an hour and 15 minutes, it's almost like an hour and a quarter, like Niall said.
Yep.
So if it travels 40 kilometers per hour, it would go 40 plus a quarter of an hour. A quarter of 40.
Which is 10. So it comes out to be?
So I've traveled 50 kilometers in an hour
Yeah.
and 15 minutes.
So she's saying 40 times 1 is 40 plus the quarter of 40, 10, adding them up. That's how you should do mental math. That's really good. Okay, so the distance in the first leg of the trip is 50 kilometers. That's the distance in this part right here. Just I'm showing you color-wise. The black distance in the beginning. Now, we still need to figure out the distances that the other two cars travel, but we know that they're traveling for how long? How long are they traveling now? The blue and the red, from here to where they meet, that's how long of a time period? 2 hours. And remember yesterday, when I had two of you guys stand back to back and walk apart from each other, we said that your rates are kind of added together. It was somebody walking at 6 miles an hour and the other at 8 miles an hour. It was like you were separating at 14 miles an hour. Now it's the opposite. Think about it now. This guy's driving this way 40 kilometers an hour. He's at 55, so it's like they're moving at 95 kilometers per hour for 2 hours. Again, take the 40 and the 55 at the same time. It's like they're moving together at 95 kilometers per hour for 2 hours. So do that distance. It'll give you the remaining distance and add it together. Okay? Make sure tonight you work on the homework. Okay? It's on the next page. If you need to, it's already recorded. All the videos I've recorded are complete. So if we ever finish and we can cut it short, you can see that there. Lots of videos to watch if you need to tonight. Okay? If you want a challenge, look at the third one with the asterisks at the bottom here. Okay, if you want someone to challenge you a little bit, maybe look at that video tonight.